Hello everyone, welcome back to ABI-DOS, where we finished up not Shifter, but Sifter yesterday. Oh, and I see here it tells you how many completed levels you have to do to unlock any future level. Okay, interesting. Fine. So Sifter was one where we learned about signals. We learned about colors and... They called signals? I think it was signals. Triggers, maybe. Triggers and sensors, yes, okay. So let's see what's going on with Comparator. We already know you test two U-bits when you add them together, right? So we're probably gonna need to like duplicate both of them, and I don't know. Let's see. Identifies differences between two signals. Read X and Y as pairs. If the same character, okay, these are characters, is found in both signals, send it to output. If they mismatch, send a hash instead, which is 151 in red. You need to manipulate the characters' associated values to compare them. Well, yeah, we don't know any other way to work with things than by number. Okay, fine. So values can range from -999 to 999. But when transmitted to any signal, i.e. an input or an output, they're clamped in the 0 to 181 range. Interesting. Okay. Weird range. Can be multiplied or divided by negative. Yeah. Click on the tile of a signal. Okay, so while you're stepping through things, you can click on a signal and it'll like... I don't know exactly. I don't think I need that. So what are my new things? An ET. An ET and a net? I don't know. If the signal is X, oh, equal to and not equal to. Okay. Well, not quite, right? Because we have net and et, and we also have et and not et. Net? I don't know, are these... So let's say I take one of these, and I put it next to one of these. If I change its mode, it does just become the other one. These are two variants of each other that are listed separately for whatever reason. Oh, actually, if I mouse over it... Okay, I don't know. Yeah, I can't see any difference between these two. So, if the value is equal to X, enter state B, otherwise A. So I think this is our... Well, I don't think we can just use bumping U-bits into each other, and because we found a comparison operator is to like bump two U-bits into each other, and then they add their totals and go in the direction of the bigger one. And I said you could use that as a kind of test and add. And in principle, it seems as though you might be able to use that to implement this, right? Because find whichever one is bigger, and like if they're not bigger, something. But the problem is that what happens if they're not bigger is the U-bit just goes in a random direction. So that doesn't really help us. So I think we have to program a sensor, and this is we're gonna like writers or something, right? Isn't that a thing? Why do we have again? This is like a single tick conveyor versus like a modal conveyor. Kind of. So I kind of thought I would want... I saw something I wanted, like a... I thought there was some way to set, like, to change the mode of a thing. Because I need to set the X for one of these, I feel like, right? Here we go, it is a writer. Yeah. So I feel like it's interesting because... Oh, X can only be from 0 to 9? Interesting. Ah, well, no, writer A. You can set the X, which we would just set to like 1. We could, right? This seems to me like the obvious way to implement this is to use a writer. Oh, well, hang on. So what is this? How does equal work? Yeah, it checks X, and X is something like I would put 5 in here or something, right? But, you know, or X, like what is X? X is 124. If I write 124 in here, you know, I could say, oh, is something equal to 124? But that'll only work for the first byte. It doesn't work for inputs after that. And so I feel like what I'm supposed to do is read one of the U bits and use it to write a value to an equal to sensor and then run the other U bit through it. That seems like the obvious way to do this. But it's telling me this is not a recommended tool to use for this puzzle. So I'm missing what the obvious good one is somehow. And I have no idea. I can't find it. Was there more hints here? I don't think so. It's very strange. I just don't see any other tool I could use. Like, no, there is another tool I could use. I see. I could subtract the two of them from each other and say, is the result 0? That's true. Okay. Or no, wait. I can't do that either. Right. Well, we don't have any icons that take 2 U-bits at a time, right? The only thing we can do with 2 U-bits together is add them. So is there some way I could negate one of the symbols? Like I can subtract X from the thing and get like X minus 50, but I want like 0 minus X to get a negative version of it. I don't see any of this. Like negator I have, but it just checks whether something is 0. Oh, I mean, I think I should just use the writer. It would be interesting. Writer B, I think. No. Writer B writes X. Writer A writes the value of a U-bit into something. So, okay, let's check this, actually. Can I do this? I want it to have a value of 1, so it points at this cell. Oh, I can't test it, of course, because 124 is already there. Let's say that's 0. Step, step. Yeah, now I get this. So this seems like it would be a great tool, right? I could test whether this is 124. Like so, right? Although I think I need to allow a little bit of time for that to get there. Yeah, so now I have this. Now what does it do? It's a signal, right? Reverts to state A. So when triggered, connected triggerables enter B. So I want a conveyor like this. Oh, and do you know what? Remember last time we used one of these signals in the sifter? I had this problem where... Oh, let's look at my other solution. I couldn't feed inputs through as fast as I wanted because when I had it like this, it was triggering... Like, input number 0 triggered this for itself, but before it had a chance to use that, input number 1 rewrote what this was going to do. So I wonder if I had used a different kind of sensor. Wasn't there one of these that, like... Oh, right. A different conveyor. Conveyor B. So it enters state B for 1 cycle and then goes back to A. So if I did this, could I actually have the best of both worlds? Well, it's hard to tell until we get to a case where it changes from red to... Okay. Nope. Okay, well... I don't really understand what it means then. I guess it's... Oh, whatever. I want, like, the signal to be delayed by a tick or something. I don't know how to do that. So, anyway. Right. And then I need some red wire connecting these. Actually, let's ask for a new input after we've done that. Like so. We just confirm that this much works. So when it's equal, it goes up here. And we'll just throw some recyclers in so I can test stuff before I go and wire it up. Now these are not equal, so it should go here, right? But it went up anyway! I don't want to stop the simulator. I want to inspect this. Ah, what happened? You went away. But I thought this... enters state B. If they're equal, it enters state B, which this... If triggered, it enters... Oh, we're using... What kind of connector do we have? How could I even tell? I think I want a conveyor A, right? Oh, this conveyor isn't triggerable. I see. B and C are the two I have to work with. So B changes for 1 cycle. C goes indefinitely. Okay, and so now this is, I think, backward. But yeah, it's separating them the way I want it, just backwardly. So I could change, how do I forget how to change. Is it like shift click or something? Double click or press Q. Oh, no, that just changes not the meaning of A or B. Oh, no, state A active, state A inactive. I see. Okay. So I can say, let's see, God, this is confusing. When triggered, it'll enter state B. So state B, we could say, is active by setting state A to be inactive. Oh, I could reuse this recycler, couldn't I? Yeah, that would be kind of nice. So A inactive. I want the opposite of that, though. I want A, i.e. they aren't equal, to be active. Push it to the recycler. if they are equal, i.e. state B, then write it to the output. But I don't want it to just go to the recycler, do I? What am I saying? I need it to be turned into a whatever, the red hash. Well, I guess that's easy. I was thinking, I don't know what. I was thinking it was going to be awkward to route them back here in the right number of ticks, but it's just easy. I need a colorizer and a definer. Where I colorize it to red and define it to, what was it? 151. So what do we think? Does this look okay? When I mouse over, I can't tell what state this is in. But the 124 got sent out, and that's what we wanted. Now these two are unequal, and so we should write a red order, though. Is gonna. I actually am requesting my input bit too soon, because the path from here to here is so much faster than the detour path. I need a cycle length of 3, not just 2. I need something like this. Or a better way to do things. Actually, wouldn't it be better for throughput to... Okay, so here's an idea. No. Yeah, if I do this, so that we don't actually go straight from we don't go on a straight line. We always take the same length of time to get from here to here, whether it's equal or not. And that way, if I process one U-bit, I never process one U-bit more slowly. So there's no time for the new one to get to the output before the old one can. There'll be a little bit of delay here. This adds latency. But it helps me keep throughput high by being more uniform. It's still not as high as I would like. I wish I could do it every tick. I don't totally understand why I can't. But let's see first if this works. This looks great. Yeah. Still no challenge mode is. Let's actually back out and go and see, is there why is it that I can't do this every tick? I mean, it's... I should be able to, right? Because... No. Because this writer sets the state this is in. And I don't know exactly, like, it must... that must take effect like a tick after the writer writes it, right? It can't happen on the same tick. Like, when a U-bit gets to here and a U-bit gets to here, well, I mean, okay, I guess I could just test it by doing this, right? This will keep them in sync with what they were before, but request bits more quickly. Yeah, so the thing is, this... I don't know. Yeah, these are being sent nonsense directions. This is incorrect. It's because this sensor is controlling the conveyor using the same U-bit that wants to move along the conveyor, and so the one behind it gets... It's the same problem as the last puzzle. And I feel like... Conveyor B is the one that's supposed to do this. That's supposed to set it for a tick. But the thing is, it's like the current tick and not the next tick. Whereas I would want it for the next tick. And we could solve this problem the same way we did on the last puzzle. Making a copy of this guy to stand on the sensor while the other one is standing here, basically. Right? It would cost us some area and a little bit of startup time, but the total throughput would be improved. Plus, it would cost us some symbols, like icons, rather. It would look... What would it look like exactly? How would you do this? I can put this here, that's fine. This has to, actually I could just say that that's 2, set it 2 away, set this one. Can't write number bigger than 2 here. So I guess it's actually sort of like duplicate it going that way, right? So now it'll be standing here at the same time as its copy is standing here. And while that's happening, this will be set. Is that true, or will I be off by a tick? Yeah, I'm off by a tick. So this needs to get a tick sooner, have a little bit less delay, which I can't do. So instead I have to give this a little bit more delay. So now 124 is controlling the other 124. At the same time, we're about to rewrite this to handle 104. Is that correct? No! Alright, so what does the debugger actually do? This is completely useless. I mean, it's not useless. It tells me what inputs and outputs I want, but that's not what I care about. This is interesting. I don't even know what matches are. So this tick, I'm overwriting this to say 124. So this... And then at the same time, this... So I don't understand... Either we were too fast or we're now too... This is what I had before, and it also didn't work. I can't set 124 and use... Oh, hang on. I'm stupid? Okay. I figured out the problem, I think. Maybe. I forgot to wire this up when I changed... Oh, not... This is incorrect. This. There we go. So this conveyor just wasn't wired up at all. So probably this one of these two should be fine then. That looks good, good, good. Okay, great. I guess this could go there, eh? We could save on icons, of course, by reusing the recycler at the cost of some space. This is my throughput solution. Go fast. Whee! Yeah, so that improved my cycles and worsened everything else, which is what I intended. And my icon solution was pretty good. Space wasn't as good as it could have been, huh? That's interesting. 10 icons, 13 space? Oh, because of this, I see. And the delay here, yeah. Well, whatever. I'm happy with it. So we can either work on a data size calculator or a call corrector. What is a call corrector? I don't know. Let's just do them in order. Data size calculator. This program computes the size of data packages. Oh my goodness, what are these? X supplies a sequence of data packages ending with a hash 151 in red. So that's like our generic error bit, U-bit. For each package, tally the number of items. Oh, this is like strlen? Okay, excluding the hash symbol, and transmit it to the output. What? Okay. So an obstructor stops a U-bit and starts a countdown that decreases each cycle. So you can set. We looked at obstructors before, but never used one. So we set their X to be a number of cycles. If X is -1, it stops it indefinitely. Active by default can't be modified. Okay, so you can say how long you want to hold on to something, or say you want to hold on to it forever and release it on a signal, which is probably what we want. Ooh, what is this? Oh, breakpoint. They're suggesting that to me now. Sensors that can use any U-bit. Okay. Yeah, no problem. I feel it's strange they're teaching me about obstructors here, because the obvious algorithm I can think of doesn't involve any delays. You don't need to hold a U-bit hostage and keep adding 1 to it. You basically are going to have a U-bit kind of circulating that he keeps as its value the number of bits seen before it, basically. Oh, but hang on. So the first U-bit that comes in as part of any string, are they calling these strings? I've forgotten already. A package. When a U-bit comes in, we won't already have one that says, oh, I've seen 0 before. So tell me again what happens when, if a U-bit collides with a U-bit that's held. What in the hell does this mean? The countdown state of the stopped U-bit is transferred to the resulting U-bit. So I think what it's saying is you add together 2 U-bits because they collided, and the obstructor keeps holding on to them for as long as it was going to hold on to the original one. Very strange way to write that, but okay. I mean, I guess we could find out. Could we? I don't know. Oh, of course, I can't even see. I can't read the obstructor while there's a U-bit in the way. Is there some... Hold down Q. So it's in state -1. Yeah, so they're being added up and staying at -1. Fine. If I set this to like 6? Hello? 6? Okay, it says... Oh! This little thing at the bottom of a U-bit, apparently... Okay, hang on, I'm gonna have to actually, like, have somewhere to go. So this says how long the U-bit is staying here, kind of? Interesting. Strange to have such a rarely used, I assume, a feature be so prominent on U-bits. But okay, so yes, they're added together and it doesn't affect the countdown, is what that's telling me. But it's telling me in a weird way because the countdown is a property of the U-bit and not of the obstructor. Fine. So one of these, yeah, spawns a neutral U-bit. So I think I want this, don't I? When someone says go to state B, it spawns a U-bit, and also it spawns one at the beginning. So I can assume that there'll always be, as like an invariant of the process, there'll be a U-bit counting how many symbols we've seen before the current one. And I suppose we can have it held in this obstructor thingy, right? Now, it doesn't actually tell me we won't get any non-red hashes or any red non-hashes. But it looks from the example input like we're getting red hashes and color, white other stuff. And we're meant to count the white other stuff. So you could use either a color sensor or a value sensor, maybe. But a color sensor would be the most clear way to say, we got something red. And so I think the idea that I have is that we're just going to test every U-bit when it comes in from the input and say, are you red? If it is red, I'll send out a signal that releases the held thing at the obstructor to be written to the output. And also requests a new input and a new neutral U-bit to start our counter again. I feel like you'll have to time it sort of, I don't know. How quickly could I run this? What would be my best throughput? I'm not sure. Okay, so neither of these are triggered by signals. They just use signals or sensors or whatever to control what they request or something like that. I don't know. So it's weird that it says port X. I don't know. But X doesn't seem to be like, it's not a value. You could write 5. Like, you can't write 5 here. It doesn't mean anything. So if I do this, we get a 0, and so we're kind of tracking this. And we can connect to this with a sensor, sort of. And say, like, This seems like another case where I want a U-bit, a sensor for a U-bit to control the direction of that same U-bit. And as far as we've seen so far, the only real way to do that is to make a copy of it. Like so. It's like a programmable conveyor. Like this, lined up with red tape. Or like this or something, I don't know. No, I guess it would be like this. And like carrying on this way if this doesn't make it happy. I think I might need a little bit more room. I'm not sure. Because somewhere in here I have to ask for the new bit, right? But I also have to make sure I set this thing's value to 1. Or do I? Do we ever have just 2 hashes in a row, an empty package, kind of? I don't see any zeros down here, so probably not. Maybe that would mean something. I don't know. I could basically say make this 1. And then request a new bit, kind of. I wonder what the blue wire is about. We haven't seen that before. Is it the same as red wire, I wonder? Just like you use it so that you can route blue and red through each other without connecting them? Maybe. So if this is red, this sends things into state B when it's active, right? So I want state B to be actually go this way. Go there, but also go there, right? Oh, and also here. Get us a new accumulator, basically. So what does this do? Does this do anything at all reasonable? You get a 0 here, and it's waiting. 156 is not red. Ah! Of course, I need to recycle that. And since it's not red... Oh, I did it backwards, didn't I? This actually I want to be... Yeah, okay. So if you detect something that's actually red, throw it away. I.e. turn this off, otherwise leave this on. Well, but hang on, why? Huh? I mean... Oh, the direction got a little messed up because this... Oh, yeah, of course. Well, the bigger one will have come from here, right? So don't I want, like, this? Plus, now they both want to turn... This wants to turn right, and this one wants to keep going straight. So that'll send it to the right place. Putting a 3, that's what we wanted. And now we're back at the original pristine state. So this is exactly what I hoped for, I think. Yeah, it's looking good. Go fast, please. Have you detected a mistake? I don't understand what's happening. Like, I don't see any mistakes here, but it's like pausing for some reason. If I said go fast... Huh, now it's going. I don't know. So that was correct. Oops. I didn't want to leave yet. At the very least, we can save ourselves a little space this way. I don't think this is especially efficient on any metric. Yeah, now it's running everything. I don't know why it kept, like, stopping. Yeah, atrocious on cycles, because it takes me forever to ask for the next bit. Bad on icons, bad on space. I don't really understand what else I was supposed to do. Like, right? Obviously, the multiple recyclers I could do better. In fact, if I wanted to optimize for icons, cost myself some cycles and some space, I could very easily just do this. Right? Reuse the new input and the recycler. Improves my icons. Doesn't actually improve my space, so yeah, that's true. But I don't especially love that. Although I guess why not? It's just a little slower. So I guess... I thought I might have some latency issues, but could I not just put this here? Get a new bit immediately. No. The problem is... Well, maybe I could, but... Oh man, I really should not be editing my existing working solution. I should be defining a new one. Okay. So let's exit there, or make sure it still works. Looking good, okay. Very slow though. Copy that, let's say into slot 0. So I think the issue I'm going to have is I'll start releasing new bits into here before I'm done, like... processing the previous one in a way. So I request a new bit be sent here. Whenever I detect something red. But I haven't... And yeah, I don't think this is going to work. Yeah, see, we output too small a number already. But maybe I could scrape by with this. A period of 2, so to speak. Yeah, that looks like it might just be okay. Okay, that's an improvement. Terms of cycles. I mean, a vast improvement, because our previous throughput was like 1 U-bit per 7 cycles or something, and now it's 2 cycles. If I could go straight from this conveyor into here at the same time that I say to release a new bit, would that be okay? And to release the one here, I don't think it would. Well, maybe it would, because we're either releasing a new bit, in which case we don't need to add anything, or we're not releasing a new bit, in which case we can be a little bit slow on adding, right? So if I could swap things around a little bit. Maybe I could get down to a latency of 1 instead of 2, which would be obviously a huge triumph. Like this little equals 1, I could swap that and put it before the conveyor. I would have to delay the other side of the operation too, but I could have something arrive here already equal to 1 if I wanted. And then I'd be pushing it here. But the thing is, I'd be sending it here at the same time that I'd be releasing the bit from here. So I don't think that works in a way that I can understand. I don't think that works. So let's just be happy with this, shall we? And conveniently, I mean, we have taken some time on this video, and it's now a reasonable time to finish. But look, I got into the lower kind of, in the bimodal distribution. I'm over on the low side instead of the high side now. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.